All right. Okay. So let's start this meeting. Let's start the webinar in 3 minutes. At in 3 minutes, so other people could join. Hello, we'll be starting the meeting in a minute, so other people could join. Okay, so my name is Jasmine, and I'll be presenting 3D insights, specifically computer-aided design, also known as CAD. So first, let's talk about what CAD is. So CAD stands for computer-aided design, and it relates to the use of computers to aid in creating, modifying, analyzing, or optimizing a design. CAD is used across various industries to create precise 2D and 3D models. For example, this plane you see here is modeled using a CAD software, where basically people who specialize in computer design would design each individual component, as you can see, presented by the wings, and engine, and body, right here and there. So they would create these designs, and they would share these designs with other collaborators and factories. So when designing, when creating and manufacturing each component, the assembly process goes smoothly because it's pre-designed to fit in together. CAD could also be used for prototype. When, for example, when creating this, they would create a conceptual design and 3D print it, or any other small model, where they could then attach it to see if each component works properly. So CAD is very essential to making sure that the things that are manufactured fit and work together. CAD can also be used to run simulations, like for the plane, you can run physics simulations to see if it is aerodynamic enough, or can actually fly and support its own weight. So to get started talking about CAD, let's first talk about how CAD came to be. with this history. So CAD first started off in the 1957 when Dr. Patrick J. Hanratty developed Pronto, which is the first commercial numerical control programming system, which is also known as CNC. So CNC programs are basically like graphic. There are graphic screens or a graphic interface, and CNC is also used as an outcome of the CAD, which, for example, with high precision things such as laser cutting or 3D printers. Those are also known as CNC programs or CNC machines because they are high precision systems that help to model and manufacture CAD programs. So in 1963, Ivan Sutherland, using Pronto, developed what is Sketchpad, which is considered the first CAD software allowing users to interact graphically with a computer using light pen. So in this image to the right, you see Sketchpad being used with this light pen right here, and it's being used to model what looks like to be a house plan or a floor plan. So in the 1970s, Hanratty founded Manufacturing and Consulting Services, also known as MCS, and produced Atom, which is the automated drafting and machining of a widely adopted CAD system. In 1977, Computer Vision introduced CAD's Computer Augmented Design and Drafting System. Both of these are basically just advanced personal computers, such as the one in this image. Back then, computers were huge, and CAD software was also pretty heavy and required huge computers. So in the 1970s, they developed a more personal way to use it, using smarter computers and allowing more individuals access to it. So in the 1980s, Autodesk released AutoCAD, which is the first widely available CAD software for personal computers, and revolutionizing the industry, allowing more individuals to gain access to CAD softwares. Autodesk is still a relevant company, and AutoCAD is also still a relevant software, and is still used widely. In the mid-1980s, CAD software began to incorporate 3D modeling capabilities and started moving beyond 2D drafting, where they basically, in the past, they would model like a floor plan, and then like show where, like for a house, it would show where the bed is, the doors are. But in the mid-1980s, they started making 3D models of the floor plan, such as including walls where depth and layer was added. Also, if you have any questions, just feel free to ask them in chat, and I'll answer them to the best of my capabilities. In 1987, Pro/Engineer developed the PTC, which is an introduced parametric feature-based modeling, and that changed the way products were designed. In the 1990s, CAD software became more integrated with other computer-aided engineering tools and manufacturing processes. And in 1995, SolidWorks released its first version, focusing on ease of use and solid modeling, becoming a significant player in the market. SolidWorks is still relevant to this day and is still widely used. So in the early 2000s, widespread adoption of 3D modeling with major CAD vendors offering comprehensive solutions for various industries. So basically, during the 2000s, CAD softwares became more adopted by other industries, such as engineering industries, architecture, civil engineering, and because it got more revolutionized, it became more versatile for these industries. So in the mid 2000s, the cloud-based CAD software allowed for remote collaboration and access. So in the previous example with the plane, now not every single CADing engineer has to be in one place. One could be in another factory, and the other could be in another factory, and they could remotely collaborate in creating the design for that plane. In 2007, Autodesk acquired Revit, bolstering its building information modeling capabilities. So, building information modeling is a process that involves the generation and management of digital representations of the physical and functional characteristics of buildings and other physical assets. So, basically, Autodesk allowed companies to basically conceptually, as shown by this diagram, they allowed companies to first like program the design, and then they create a conceptual design. So they first like map out a very generic looking building for a building, and they see if it works or not in the city landscape that it is present in. Then they start doing a detailed design where they start designing floor plans, windows, how tall each room should be, where rooms should be placed, where will the desks be, if it's a hotel, where should the beds be, how many rooms, how many floors, where the electrical sockets will be, lights, lighting, vents, a whole bunch of stuff will be covered in detailed floor plans. And they start analyzing it where they start like discussing how will this building work? Can it support its own weight? How much will the materials cost? Can we cut down on costs? Can we cut down on costs and increase safety? Or how can we ensure, that people will enjoy this? So they start analyzing it for costs, for materials. Then they start getting the 2D designs and they start documenting it where all the measurements are taking place for the blueprints. Then using CNC machines, they start fabricating the materials and start building and constructing this building. Now, thanks to CAD softwares, renovations are a lot more easier to be held. Without CAD software, in order to do renovation, you'd have to take down a building. You'd probably have to take down an entire building because there's no way you could renovate it. There's only like a prototype renovation. But with CAD software, you could take the original file with the detailed design and you could choose to redesign it and conceptualize it a bit. So you don't need to take down an entire thing. You just do a small renovation. So CAD software made it a lot easier for companies to renovate all the buildings and without spending more money on that. So from 2010 up to now, there have been continuous improvements in user interfaces. So basically, it got more simpler to use. Tools got a lot easier to use. More updates on old technology, such as SolidWorks and AutoCAD, becoming more and more modernized with more tools and capabilities. And there's been more integration with other technologies such as virtual reality, augmented reality. For example, like when you're like going on like a Redfin when looking for houses or Zillow, there's options to check a 3D model of the house itself, which are capabilities that were introduced more recently than other capabilities. Also, virtual reality such as Apple Vision Pro, Oculus, and other like virtual or other companies that create virtual headsets use CAD. Also, Blender is also a well-known tool to create 3D models. It's also known as a CAD software, and which is also used for games. So CAD software is not only used for engineering, for physical engineering such as aerospace and architecture, but it's also used for video games and the software side of things. In 2020s and up to now, advancements in artificial intelligence and machine learning are being more integrated into CAD software, helping with optimization and the automation of the design process. So let's talk about the fundamentals of CAD software. So CAD software includes tools for creating, modifying, analyzing, optimizing designs. The key features include geometric shapes, dimensions, and coordinate systems. Basically, there is a CAD software called Unreal Engine, which is also used to create games and more virtual reality. That software is also used to create animation and movies because you could create 3D models of background pieces and sets, and you can set that up for movies. CAD software could also be used to create the sets itself, designing the sets on the software before creating it in person in the physical world. So this image shows Fusion 360, which is a CAD software that I have used. As you can see in the top right over here, this is the sketch tool where you can create a 2D sketch. Then using this tool over here, you could extrude it upwards to create a 3D sketch. So the extrusion tool allows you to stretch it out. There are other tools like the revolve tool over here, which allows you to revolve around an axis. So you could create like a donut or a sphere. There is a mesh tool, which generates you a mesh. It gives you a 3D mesh, like let's say a full sphere that you can pull out and stretch to make other shapes. There are more tools over here, such as fillet, which add curves. So if you have like a cube, you can make it curved like that. Curved edge, you can add a hole here. You can make a box. There are multiple tools you can use, and the more advanced the software is, the more tools there are, and the more complicated this screen would look. This box over here represents viewfinder, so you can like rotate your screen to look at other sides of your project and continue working on like that. Down here is a timeline. Basically, each change you make will be saved. So if you want to like remove something you made in the past or edit something in the past, you could do that. And there's so many other options, such as you could make planes. There's a drop down here for all that. All right, so AutoCAD is available. Okay, so to my knowledge, AutoCAD is an app you need to install. There are other CAD softwares that you could use. There's something Fusion 360 has a desktop version. However, it's not that good. There's also something called, I'm pretty sure it's called Onshape, which is an online CADing software that is being used by some schools when teaching engineering and design. There's also Tinkercad, which is completely free, and it's an Autodesk software like AutoCAD and Fusion 360 that is completely free and can be used online. So on topic of CAD software, some of the most popular ones are, as mentioned before, AutoCAD, SolidWorks, Fusion 360. There are Autodesk created both Fusion 360 and AutoCAD, and they created many more things like Tinkercad, which is completely free and online. All you do is like make a Google account and you start creating your models right away, and you can use those models to 3D print as well if you have a 3D printer. So there are so many different like CAD softwares you could use, and now when choosing one, you got to keep in mind that they're pretty expensive because each CAD software offers different capabilities. The better softwares cost more and require stronger computers to manage them, while cheaper ones have less tools but can be used in smaller computers. Like Fusion 360, I showed you the screenshot where there's a bunch of tools. If you use Tinkercad, which is free, there'll be less tools available to you, but you're able to run it on a browser. Unlike Fusion 360, which requires some pretty beefy computers. Like I use a small laptop, and my computer starts overheating whenever I use Fusion 360 because of how big it is and how the projects I make are too detailed and heavy for my computer to land. So when you're choosing a software, you should keep in mind that there are things your computer can handle and cannot. And also the expensive. For Fusion 360, there's a subscription you got to pay. Same thing with AutoCAD, unlike Tinkercad. However, there are some like benefits you can receive, such as for students. If you prove you're a student, you could get access to Autodesk apps for free, which is what I did to run Fusion 360. All right. So the best way to get started and get better at CADing is to understand the user interface, because each interface will be unique for a software, and it is will always be complicated and overwhelming in the beginning. You will see like different tools with different names like extrude, sketch, construct, with different icons, and you'll always be confused what these mean. The best way to practice these different tools and drawing tabs is to start making small projects. Like you can start by making a box and then putting a hole in the box via extrusion, or start making a mug and design, the base of the mug where you design this part, extrude it up, make a hole up here, and then add the handle and find out how to add all those to a curved surface. So doing these small projects are very beneficial. When learning Fusion 360 myself, I used YouTube to teach me the basic tools and did projects that I found interesting to apply these tools and get better understanding myself. By following YouTube tutorials, I learned how different tools worked. By creating different projects, I learned how to apply these tools myself, and I grew more comfortable with 3D modeling completely by myself. The projects I included were making like a mug. I made game pieces for board games. I made a model train and other small projects. So it's best to start off small, and you can slowly get bigger, from a mug to a piece of candy like Kit Kat or a lifesaver to like a toy snake that could move and bend. So how is CAD applied into like jobs and industries? So CAD is used in automotive, aerospace, and architecture industries. As I showed before with the plane, the CAD software is used to model the plane inside and out with each like the electrical components, the shelling, the interior design, everything already modeled and engineered and collaborated on by multiple different people in different factories. Where using CAD softwares, they could prototype it and see if everything works and run simulations on it before modeling the real thing and assembling it pretty well. CAD is very vital for architecture, engineering, construction, product design, and manufacturing because it improves productivity, quality, and communication. It allows people to prototype the thing before creating it so they don't run into issues afterwards and have to restart and waste a bunch of money. As you can see in these images, you can see how they're developing the car engine, where they could see how the pistons would be placed, how much space there is left for nuts, bolts, the pipes, how things would run. They could run animations and test out if everything works and functions and see things like that. Some features of CAD softwares allow people to run circuitry and see things, how electrical components could run together. You can see if electrical components will short circuit, will break, or will not run at all due to problems with the design, which can all be done with CAD software. You also see in the house design, you can see how they are creating these vents and seeing how they'll be placed around the house, how the house will get proper airflow and things like that. You can see they're seeing how windows will be placed, where the walls will be, the color of the walls, and where the bathrooms and doors will be placed. So CAD software helps designing the house before building it, because you don't want to build a house and then see how the vents are not lining up. So you need to tear down the walls and rebuild it from scratch. That is a complete waste of money, and CAD software helps minimize these losses. So CAD in the future, how will it look in the future? Well, there are emerging trends in CAD, such as generative design, virtual reality, and integration. CAD software is already being improved frequently with better technology, for better graphics and more advanced softwares, where you can now run animations, animate CAD beforehand. You could also run some better simulations and have better simulating physics, such as water physics. You could run cloud physics. You can see how things interact with each other. Also with CAD, you can start creating more advanced pieces of technology, such as instead of having flat electronic discs, you can start CADing flexible ones using 3D printers and designing that stuff. AI and machine learning will also play a bigger role in transforming the industry by optimizing and refining the design process. So that is all I had to say about this. Do you guys have any questions? At the moment? All right. I might as well show off some CAD softwares. So, as I mentioned before, there's something called Tinkercad. So, which is a completely free site where you can just create your own creations. So, let me share my screen. All right. So, in Tinkercad, you could create different things where this is a completely free website where you just need to log in, create something, and you could basically design your own thing. Like I've designed circuitry here. You create rocker motors. You could check out what other people have made somewhere else. Like over here, you can see the community gallery. You can see what others have made and check out their designs. These are all 3D printable and have all been designed. This is so completely free. Just search up tinkercad.com and you can create a website. You can copy these. You can use these for yourself, and it's pretty versatile software. Now, Fusion 360 is a lot bigger and heavier to use. You can see there are way more options here. I could create a sketch on different planes. Like let's say if I want to create a cube, I could create a sketch here. I could then use the create tool over here, choose a rectangle. Let's say I want to create a center rectangle, and I could create a rectangle right like this. So I've created a 2D design here, and you can see this is a shape because like a closed shape because I could click on it and highlight the middle. Then if I finish my sketch and rotate my screen, you can see that I could extrude this upwards to create a 3D object. And I could create a hole in this object by creating a circle in the middle, like as so. And I could then extrude this downwards and create a hole all the way through. So now you can see there's a hole all the way through this 3D object, and it's right in the center. You can do way more. I could also create a new sketch over here. Let's say on this side, and I want to create some kind of donut. So I finish this sketch and I choose to revolve this around an axis. Let's say this green axis right here. Wait, I do the sketch in the wrong place. If I want to create a sketch on this plane over here, create this circle, finish a sketch, and if I want to revolve this around this axis. Okay, an error because of emerging profiles. So I'm choosing the wrong axis here. So if I revolve it around like this, I could then create a big donut. Like as so. So again, these are all versatile options. I could inspect the measurement of this, see that I created this radius. I could make a hole here as so, and have a little box there around this hole. There's a lot of things you could do in CAD softwares such as Fusion 360 and Tinkercad. They're all versatile options. You can do a whole bunch, and it's also a very good talent to have because many engineering companies use CAD software such as aerospace and automotive, where they design the stuff for assembly, because it's a lot better to design the stuff online and in the computer to see if things work or not, whether or not it's safe for runs. So the best way to learn, and in my opinion, is to first watch videos to get some kind of knowledge on tools. Like the ones I use were like Fusion 360 in 100 days. Learning these or more like practice. So the way to learn is to choose a project. I would say start off small, like how I showed you. Create like a small box and put a hole in it. Then you might want to get more and more creative with your project, such as creating a small little mug. So this will require you to make a circular object. Then you want to extrude upwards to make a cylinder, put a hole in the cylinder. Then you want to create some kind of curved handle that attaches to the curved cylinder, which is pretty difficult because there will obviously be some parts that don't fully connect. So finding ways to overcome this issue could make you learn more. After this, you can start thinking of doing other projects such as measuring and redesigning a box for your cabinet, or recreating your water bottle, or any other objects you use in your daily life. You can start recreating those and learning how different features work. When you get more comfortable with these parts, you start creating models for fun, such as toy models, such as like puzzle boxes. You could create a maze, a marble maze. Start creating fun, or like a helmet. You start creating small projects that you have that using tools and abilities you have practiced and learned with other projects. The best way to learn would be through trial and error, in my opinion. If you need to learn some specific tools, you can search up the tools. You can search up how to use revolve, how to extrude, how to construct a plane, or how to create an object in an angle. If you want to know, because it's all a lot of stuff is available online because a lot of people use these softwares, and these softwares have been around for a very long time. Almost all CAD softwares have the same exact tools. Both Autodesk, SolidWorks, they all use tools like sketching, extrusions, and revolving. All these tools are available. It's just that these simple tools are available for all softwares. Some tools are not, such as in Fusion 360, you might have a tool that allows you to animate your individual components. So if you want to animate an engine working or engine moving, you could use Fusion 360 to make and move. However, for cheaper softwares might not have that same capability of animation. Any other questions? All right. So, seeing as how there are no other questions, I call this webinar over because I've talked about everything about the applications and how to get started with CAD. All right. Thank you for coming and listening to me. And yeah. All right. Thank you all, and goodbye. All right.